Hello, class. So I wanted to talk about the last lab that we did, and it was the factorial. Let's program a factorial, and I wanted to do it in a console application. We had a lot of time to do it. Most of you struggled with it. I was surprised because the bulk of this challenge was really a logic problem. It was not a programming problem. I wanted to have some fun with it, which is why I put us in groups so that we could have a little bit of fun and do it. I did get some a little bit of feedback that was not enjoyable. I'm sorry for that. Like I said, that there was nothing new here. There was no new coding, no new concepts. This was pure logic. And so I went ahead and wrote the hand coding part of this program out. And I did that because hand coding is a important part of programming, in my opinion. If you write a loop or something, some type of algorithm, you need to hand code it by hand, putting in variables so that you can see how things are coming out. It's an easy way to visualize what's happening. So factorial, the definition for factorial is simply any integer that's an integer which is the product of all the positive integers that came before it. So I give an example of the factorial of 1 is 1, the factorial of 2 is 2 times 1, which is 2, and the factorial of 3 is the integers that came before it, so 3 times 2 times 1, which is 6. So here's a little example of your factorials. Now I walk through the actual logic, and so I'm going to set this up. I'm going to use n, and n is just going to be a number that I use, and I'm going to set that at 1 because we need to start at 1. And I say here because you look at line 4, we got to start at 1, so we're going to start at 1. That's n. P is 0 because it doesn't matter what p is. P is just an initial starting value. We could have set that at 20. It doesn't really matter. It's just going to be whatever we start at, and that's because p is going to be the product. I'm going to use n as storing the product, and so the way we solve this is we have a nice little loop, and in the loop we use a for loop. The for loop, you can do this in different ways. There's multiple right ways and probably multiple wrong ways, but I chose a for loop, and for loop is just the easiest way to do this in my opinion. So I'm going to declare I as an integer 16, and we're going to go through the loop, and we're going to go from 1 to f. What's f? F is the actual input that we're going to be running through. So in our case, f is going to equal 3. We're going to use p, so and this is where p starts. P is going to equal I, whatever I is, times n. And the first iteration, I is going to be 1, n is going to be 1, and then n is going to be whatever p was. So because n is always storing our product. So here we are. We're going to do the factorial of 3, and we're hand coding. So the first loop, the first iteration, I is equal to 1, as we got from above, and that's because we're sequencing through the for loop, and we're incrementing every time. So it's going to be 1, 2, 3 until it stops. And in this case, we're stopping at 3. So first loop is I equals 1. P is going to equal I times P times n, and in the first iteration, I is equal to 1, and n is equal to 1. So P is equal to 1 times 1, which of course is 1. N is equal to P. P was 1, so therefore n is 1. Iteration number 2. I is now 2 because we incremented I by 1. So I is now 2. P is equal to I times n. I is equal to 2. N is equal to 1 because of up here. And so now n is equal to 2. Because 2 times 1 is 2, so therefore n becomes 2 right here. Iteration number 3, I is now 3. P is equal to I, or excuse me, P is equal to I is 3 now, so 3 times n. N was 2, calculated up here, so now it's 3 times 2. I is 3, n is 2, therefore n is now equal to 6, the product of 3 times 2. Return n, which is 6. So this is the hand coding. So take a look at this, read through it, make sure you understand it. More importantly, learn how to hand code. When the next time that we do an assignment like this, you're going to want to be able to run some variables through and go iteration by iteration until you make sure that you understand how your loop works or how your logic's flowing. So now let's move this out of the way and let's talk about some code. All right, and the first thing we're going to do is a lot of times I like to write my functions first. I'll comment it out because it's not written yet. So I'm going to be calling, in this case, the factorials. I guess I'm just going to call it factorial. And it's going to be, we're going to pass it something, probably, I guess f would make sense. And so I just want to go through this and kind of give you guys an example of how simple this is. And of course, we need a variable, so let's dim something. Declare f as, let's see, int 16. We need a large value because we're going to be passing big numbers. And we'll go ahead and set this as, we're just going to test our numbers, so let's just set it as 4. And then, let's see now. Oh, we need to pause our console, so we need to output this. Console.write, good enough. If console pause. So in this case, it's going to be read keys, usually the one I use. Okay. And so now, at this point, we have a variable declared, initialized to 4. We're passing f to the console. So if I was to run this right now, it should just output 4, and it does. And we want to compile every once in a while, make sure that our code makes sense. Okay. So now we have the beginnings of this. Now we can actually write our function. So I'm going to do my factorial. It's going to be f as int 64. Okay. Now that I have a function running, I can then comment this. But I usually set mine up right away so that it's functional right away from the beginning. I'm going to want to create a variable, and I'm going to want to set up my return. And I'm just following the hand code that we just went through. Okay, and p is 16 equals 0. Again, I'm just following the hand coding that we did. We have int 16. P is going to equal 0. N is going to equal 1. And now I got to set up my loop, and it's really not very difficult. Okay, so of course there's no equal in the return. It's just returning. Okay, so now my function is actually my function factorial is actually set up now. I just got to put the logic in, and the logic is really simple. So let's do that. Again, I'm just following my hand coding. And that's it. It's done. We take in the factorial f that's passed in right here, and I'm just going to test 4. And we assign n as 1 because we need to start at 1, just like I showed you in the hand coding. So let's put the hand coding back up. And p is going to start at 0 because it doesn't really matter what we start at. P is just going to be the first product. We're going to do a for loop for I. We're going to start at 1, and we're going to go through all the way up to the factorial, and that's where we're going to stop. So whatever the factorial is, in this case 4, we're going to stop at 4. P is going to equal I, so 1. times n, and you can see the loop as we loop through each loop, each iteration. So I'll leave that up for a second so you can study it. Okay, now let's move that out of the way and let's run this. And oh, so I still, because I didn't call it factorial. So one moment, and this is where we get a troubleshoot. It's always kind of fun. So what's happening here is I passed f as 4, and so it didn't run the factorials all that happened. So easy wheezy, we just do that, and voila, the factorial of 4 is 24. Yep, that's right. Okay, escape. And I would do it this way first before you have the user input, because I just want to test my function, make sure it's right. So let's start with the 1, and we'll just go through it. Yep, the factorial of 1 is 1. Cool. Let's go through 2. Factorial of 2 is 2. Cool. We know that's right. Let's do 3. Factorial of 3 is 6. Yep, we know that's right from our hand coding. Cool. We already did 4. Let's do 5. 5 should be 120. Factorial of 5 is 120. Cool. So we just tested now you see how I want to emphasize how important the console is, because by using the console and hand coding right here, just giving it hard codes, you know, we're testing our function very quickly, very fast, and we're able to see, is it working, is it not working, without any other issues. If I wanted to now, I could very easily take this function and now copy it and plug it right into a Windows Form application, a desktop application. So this is how you want to do it. You want to hand code it very quickly. You see how long that took? That was nothing. That's literally what it should have taken you guys in class. Okay, but we'll go back now and let's make a couple other changes now. And what we're going to do is we need to make it work the way I said I want it to work. So we want the console to input. So let's do console. And this time we're going to say dot right line. And let's put enter F. I'm just saying enter F. Keep it simple. And now underneath that we'll say F is equal to F. Of course I can't do it like that, can I? Nope. Because this part here needs to be below. So let's take that. And we're going to set it right here. We're going to comment this out because we don't need that anymore. That was just for testing. But now that we know it works, we don't need to test it anymore. Now we just need to make the rest of our application work. And F is going to equal console.readline. There you go. And there you have it. That's it. Let's test it. Okay, so read line. Let's say 4. We know it's supposed to be 120. Ah, and that did not work. So let's find out what's going on there. Oh, we didn't call our console. So not a big deal. There you go, 4 equal 120. All right, let's do another one. How about, remember that 20, so let's go all the way to 20, so let's run that one. Oh, and it blew up. So let's find out why that happened. It's a good example of troubleshooting and checking your data types. So I knew that I had to work with large integers because the factorials get large really quickly. But if you look at P right here, where it's at a 16. And that was a mistake. That needs to be a 64, so it can handle a larger int. Now I can be low because we're only the largest factorial we're going to go through is 20. So this can be a 16, but these other ones need to be large at 64. Okay, so let's run it again. and let's run 20. And there you go. Perfect. All right. So having done that, we need to clean up some code though, because up here we left it in our testing variable at 5. We don't really need that anymore. Let's fix this a little bit. And if you wanted to, you could also do, we could change this a little bit too. Let's see, console F, enter F console read line, that's right. So what you could do is you could consolidate this line right here. So we could do away with this and do that, do Control X and do that. And this would be cleaner. Okay, so we have our function, do F, okay. It would be even cleaner, we could do this even. And get rid of this. Okay, so console right line enter F, dim F as int 64 equal to factorial. We're gonna pass it that. Okay, is this all working? Does that look right? Yeah, that's looking good, I think. Okay. See what happens. I don't even know if it's going to work. I haven't done this, so let's find out. Yeah, okay. Let's try the big number. Yep, cool. So all that is working. All right, so this was really the bulk of the assignment. I know I had some other things I wanted you guys to do, but there's no reason for me to go into the while loop and the exiting part. I wanted to show you the meat of the product of the project, which was to create a factorial function. The logic behind doing it, I'll go ahead and throw my hand coding back up. So hopefully you can pause on this page and walk through the factorial. So here again we're doing a factorial of 3 in the hand code. I explain it iteration by iteration. On the left hand side we go through all the code. Console right line, we ask the user to enter a factorial, then we declare F as an int 64, so it's going to be large, and then we're going to pass it the console read line, and also it's going to be we're going to run it through the factorial function which we created below, and everything needs to be an int 64 to handle large integers except for I is an int 16, and that's because that's the number that we're iterating through. So the highest number we're going to see is 20. 1, 2, 3 up to 20. That's the highest that we're going to go to because the factorials get large very quickly. I explained the for loop and why we start at 1 and why we start at 0. That's all explained and farther explained in the notes here. That's it. So as you can see, this was not a challenging project. There was no new information here. This was purely a logical, an exercise in logic and critical thinking. So if you struggled with this, you really need to think about this a little bit deeper, because this really wasn't that difficult as far as the difficulty scale goes. And in our world, the world as a programmer, world as a anything to do with really in our world of technology, the writing an algorithm becomes challenging very, very quickly. You need to be able to hand code. You need to be able to understand your process and encode quickly. Again, I wanted to emphasize here also the console. Do you see how the console, I used it to rapidly test my factorial function and make sure it was working or not working very, very quickly. And that's the beauty of the console. Very quick testing, so that way you can take a function, paste it into your true Windows form application if that's what you're building. All right, that's it. Happy coding.